Welcome to the Effective Engineering Manager podcast.
Hey Slava, it's good to be here. It's your time today. What would you like to talk about?
Today, I'd like to give a checklist for an effective software development lifecycle, or SDLC as we know it, and its contribution to the engineering excellence.
Very interesting topic. So, what's engineering excellence and how does effective SDLC contribute to it?
Teams that achieve engineering excellence build software that customers love to use and that engineers never have to worry about. And the effective SDLC is a set of engineering tools, processes, and practices that enable teams to build software that customers love to use and engineers never have to worry about. And this set of engineering tools, processes, and practices is not new. And I know it works because I've done it a few times and it allowed me to deliver high quality software on time. And I'm not going to go into the merits of each of the items today because most of them are self-evident and well-known and lots of books are written about. My goal is to give engineering managers a clear, direct checklist that they can use to understand what is missing and what needs to be done. We will give detailed management guidance for some of the items that we still see challenging, or if our listeners ask us to cover them. I'm not going into making of the operational excellence. We'll have a separate podcast on that. Personally, I use this checklist to do gap analysis when I take on a new job as a manager, and also check myself against it as I build and develop engineering organizations. So to build an effective SDLC, engineering managers must achieve, and I emphasize must achieve 100% coverage in the following areas. Requirements must be documented and presented in form of user stories and use cases. Number 2, the team must use a version control system for managing changes to the code. There must be an issue tracking system for tracking work. The team must use an IDE which is standard for the team. There must be a uniform code style across all teams. There has to be an automated way to build a product from the command line in form of build scripts. There must be an iterative software development process that allows teams releasing working software into the hands of customers on a regular basis. Designs must be reviewed by peers. The teams must write unit and integration tests and strive to achieve 100% test coverage. All changes to the code must be reviewed by peers. Unit tests are required as a part of the commits, and they must be committed with the changes to the code. The tests must run as a part of the build process, and failing tests must fail the build. There must be static code analysis integrated into the build process, and failing static code analysis must break the build. There must be a CI system that builds and tests changes on an environment separate from engineer's machine. The output of the CI system must be a set of artifacts deployable to production. There must be a continuous deployment or CD system that deploys the product into production automatically. The CD system deploys the product gradually, watching for error rates. A reasonable deployment rate is 1, 5, 25, 50, and 100% of servers. Rollbacks are automatic if error rates violate thresholds. So that's it. It's about 18 items. And Adam, what's your experience building effective SDLC?
Well, first, I think these 18 items are absolutely critical, and I couldn't agree with you more that these are musts and 100%, or at least, having some form of all of these 18 is absolutely necessary. And I think part of the reason for that is that, as engineering teams, we are often tasked with a lot. It's a very dynamic and changing world with requirements, software deliverables, and we, I think, underestimate how much we're actually responsible for. It's not just writing code. It's the whole SDLC lifecycle as you kind of shared here. And when you're a team that doesn't have these, you realize you're actually spending a lot of time holding things together. and refactoring and reworking. You know, if unit tests are not there, you're going to be bound to find errors later down the road. You're just kind of, you know, kicking the can and down till it becomes even more costly and until somebody finds it. And the other side of it is when you do things like build a process and you automate, you create structure for a team, especially when you have junior folks who may not know any different, or people that come from other organizations that may not know any different. And having something in place and making it, you know, emphasizing it as part of the team's philosophy and practices really does contribute to your productivity. I mean, I would argue that these things alone make you as productive as you think you can be. And when you don't have that, it falls off almost exponentially because of the amount of extra time you have to spend. So just realizing how much you're responsible for as a team and being able to grow and being responsible for more things thrown your way, you have to have these things in place. And, you know, providing some structure for your engineers. You know, structure, we talk about structure and process, it sometimes is negative, but I think these are the things that most engineers would agree. It's like, wow, I know how these help me, and I've seen it work, and I'm a believer, and these are things that may be part of the process, but they're certainly important, and you know, make a much more effective and high quality product. So that's kind of some of my experience in that regard. How about you?
Well, I've done a lot, and so I started quite some time ago, and essentially learned on the job, and I think this is the worst. And one of the reasons that we started this podcast is to give our listeners something that they can take and implement without thinking much, right? Or making their own mistakes until they arrive at the same level of understanding that we have, and the same level of knowledge and practice and experience that delivers results, right? So, and I can tell that without a checklist, we often don't know where we're going, right? And when we have a checklist, and what I usually do, I even stick it on my wall somewhere in the cubicle or on my machine, and periodically check myself against it. How are we doing? And it's not easy, right? Some things relatively easy to install, like, you know, these days you don't have to convince anyone to have an issue tracking system, right? But some things still tough, and it's interesting that many engineering organizations almost start from scratch, right? It's as if there's no this body of knowledge and practice which works, right? And so my hope that with presenting this checklist to our listeners, they'll find an opportunity to review it, to maybe to print it and stick it on the wall of their cubicle, and maybe plan a bit more to do more of this and get to those 100%, however hard it is.
Yeah, I think you actually hit a really good point there when you said that in this day and age, you know, a lot of these things are not only expected, but a lot of people know about them, and a lot of these things are already easy to do. The tooling and some of these processes are very easy, and so being able to just, you know, ramp up and get these going is, I think, so critical.
Yep, good stuff.
So this has been great, Slava. Can you give our listeners a summary of things here that they can start using tomorrow?
Yes, here's the shorter but still complete checklist that engineering managers can start using to build more effective software development life cycles. Number one, document user stories and use cases, version control, issue tracking, unified IDE, code style, build automation, iterative development, design reviews, unit and integration testing, static code analysis, code reviews, continuous integration, continuous deployment, gradual production rollouts, automatic rollbacks, and high fidelity monitoring and alerting.
Well, thank you, Slava. This was good stuff, and I think everything you mentioned here in your checklist is certainly not timely, and it doesn't matter what platform or language you're using. It's all extremely important, and this is great stuff that I think our listeners can start using tomorrow and start filling any gaps that they see in their current team or organization.
Thank you, Adam. More good stuff is coming.